All right, my voice is going out, so I'm making this video just in case I have zero voice tomorrow because it's running out. All right, so this is the molecular models from what would have been today's Wednesday, from Monday, I think. Well, from Tuesday. All right, so I'm gonna show you how to do this. If I'm gonna go fast, but if I go too fast, you can push pause. All right, so let's see. First one we're gonna make is H2O. That's a simple one. H2O, oxygen, two hydrogens. Boom and boom. Let me get my little thing so I can make a screenshot of it. Boom. And take a little picture of water right here, H2O. Make a copy of it. Go to my dock. And boom. All right, there's H2O. Make it smaller to save a little space. Boom. All right. Ammonia, NH3. Easy one. Throw this guy in the garbage. Remember, if I'm going too fast, just click pause. N Nitrogen has 5 valence electrons. That's why it has 3 sticks, because it wants to make 3 bonds. Because if it makes 3 bonds, now it's going to have 8 electrons in its outer shell. That's what it wants. Like a spider wants 8 legs. All right, so NH3. 1, 2, 3. Boom. Take a picture of it. NH3 ammonia. This is what you use to clean your toilet and stuff. It's a disinfectant. Copy it back to the dock. Right here, ammonia. And voila. Boom. Make it a little smaller to save some space. Let's get rid of some of the blank. All right, good. Methane, CH4. Hard to mess this one up. It's really easy. It's all single bonds. Carbon has 4 valence electrons. That's why it's got 4 little sticks, because it wants to make 4 bonds. If it does, 4 plus 4 is 8. It'll have 8 valence electrons. So let's surround it with hydrogens. Hydrogen just wants 2, because remember that first shell only holds 2 electrons. And voila, there's methane. It's a greenhouse gas. It's released by like cows when they manure. Cow manure has methane. That's why it stinks. All right, so boom. That's one of the reasons why it stinks. Copy back to my thing. Go in here, and there's methane. Make it a little smaller, save a little space. All right, the first one where you can make a boo boo is O2. O2, you can make a boo boo. You can make a problem. You can have a problem with this one. Throw methane away. O2, you look. It seems easy. You just need 2 O's. Yay, I'm done. No, you're not. See these little sticks? That's oxygen telling you, hey, bro, I want one more electron. I got 7, but with only one bond, we got 7. But if we make it a double bond like that, now both of them have 8. Now they're happy. Let's go ahead and take a picture of that. Oxygen gas. This is what you breathe in. Oxygen gas, O2. Put that right here. Boom. Make it a little smaller. Save a little space. Boom. And boom, boom, boom. Carbon dioxide is gonna have the same thing as O2. Same. You can make the same mistake with CO2. Carbon dioxide. You need a carbon in the middle. Carbon dioxide, 2 oxygens. Oh, but look, carbon says I want 2 more electrons, and each oxygen is saying I want 1 more electron. All right, we can fix that. Double bond, double bond. Now all 3 of those atoms have 8 electrons in their outer shell. They're good. Take a picture of that. Boom. Copy it back over here and paste. Boop. And there you go. CO2. Make it a little smaller. Save a little space. All right. All right. The next one is hydrogen peroxide, H2O2. Sometimes you put this on if you get a cut on your finger. It's like a disinfectant. H2O2. We need 2 O's. Bond those together. We need 2 H's. H, H. And there it is. H2O2. Let's go ahead and take a screenshot of that. So you just needed single bonds in this one because all the outer shells are full with just a single bond. Back to my thing. Oh, is there going to be room in here? Oh, we can make it smaller. Maybe we can get it to fit in there. Boink. Good enough. Hydrogen cyanide, HCN. This one you can make a mistake with hydrogen cyanide because single bonds aren't going to do it. Hydrogen cyanide, HCN. All right, the hydrogen's fine because it's sharing one. It's got one of its own electrons and it's sharing one with carbon, so he's fine. He's got 2. That's all he wants. Carbon says I want 2 more. Nitrogen says I want 2 more. Well, we can solve that easily. Let's just make a triple bond here instead. Everybody's happy. Boom. There we go. Hydrogen cyanide. Don't breathe this in because it's highly toxic. It's a poison. Hydrogen cyanide. Copy it here and right here. Boom. All right, hydrogen cyanide. Shrink it. Get rid of some dead space. All right, now the tough ones. I'm gonna look at this. I'm gonna look at the structural formula: CH3CHNH2COOH. Now I got this kind of memorized. I'm gonna use this structural formula right here to help me build it. All right, so let's go back here. Throw this guy away. All right, so the first part was CH3. All right, start with a C. H3. One H, two H's, three H's. Then it said CH. All right, so let's bond a C here. And it said it needs an H. And then in parentheses, it said NH2. All right, so let's put an N, nitrogen. H2, let's put two hydrogens on that. So that's good so far. And then it said COOH. All right, here's COO, so it needs an oxygen and an OH, which is an oxygen with a hydrogen bonded to it. Looks good, except we have two little sticks. Oxygen says I want one more electron. Carbon says I want one more electron. No problem. Let's make this a double bond. Voila. All right, go ahead and take a picture of that. And if yours looks anywhere near close to that, just take a picture of it and put it in your little spot. Boom. And back to my worksheet. And it goes right here. Boom. Smaller to save some space. Glucose. Super hard unless you know how to do it. Unless you know the trick. And I do. All right, so you go here. Throw this guy away. Boom. Go to build from formula. Click. Hit cyclic. Click. Hit next, 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 next until you get C6H12O6. That's glucose. Click show Lewis structure. Boom. And now look, it shows us how to do it. So it starts with there's a ring in here with 5 carbons and 1 oxygen. So we got to make that first. So start with a straight line of 5 carbons, 1, 2, 3, 4, 5, and 1 oxygen. And then click make cyclic and it'll turn into a circle like that. And then just look, this carbon right here needs a hydrogen and a carbon above it. All right, so that's this one. It needs a hydrogen and a carbon above it. Boom. This carbon needs a hydrogen on either side and an OH above it. All right, so we need a hydrogen on both sides, hydrogen, hydrogen, and an OH above it. So we need an oxygen bonded to a hydrogen. That's an OH. Boom. This carbon right here, it needs an OH on top and then an H down here. So it needs an OH right here, O, H, and an H down here. This one needs an OH and an H. It says right here, OH and an H. So this one's an OH, boom. Boom. Get on there. Come on. There you go. And an H. Boom. This one needs an HOH. 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 And voila. And the last one's right here. It needs an HOH. HOH. O. This one's sometimes hard to get on. Get in there. No. Get in there. Get on there. Dang it. There we go. Got it. All right, so there's your glucose. Let's go ahead and take a picture of that. Boop. Make a copy. Back to my dock, and I'll put it right here. Save some space. All right, good enough. And then we only have 2 questions. Number 1, what does the term valence electrons mean? That is the electrons in the outer I think there's only one outer, 1T, yeah, shell in an atom. And so those electrons in the outermost shell, those are the ones that are forming chemical bonds, not the ones in the inner shells, but the ones on the outer shells. How many electrons does nitrogen, how many valence electrons does nitrogen have? So you just go look at the periodic table. Group 1 with hydrogen on top, these guys have 1 valence. Beryllium, these guys have 2. Skip all these transition metals. Go over here. Boron, this group has 3. Carbon's group has 4. Nitrogen's group has 5. Oxygen group has 6. Fluorine's group has 7. And then helium's group over here helium has 2, but the rest of them have 8. All right, so nitrogen has 5. Oh, I shouldn't have done that. All right, nitrogen has 5. We need to go up. Here we go. Nitrogen has 5. And 3, go ahead and skip it because it's really difficult. All right, so that's it. And everybody should turn in for full credit.